Reference angles rules. So we're going to talk about the concept of it. So here's the definition within the textbook. If theta is an angle in standard position meaning starting from the right side of the x-axis, its reference angle prime, is the acute angle formed by the terminal side of angle theta and the x-axis. So basically the angle with the terminal side and the standard position, or in the other quadrant, the x-axis. So if you look at these four visual examples, you see that angle theta prime, they're all connected between the x-axis and its terminal side. The reference angle theta prime for any angle theta 0 degrees less than angle theta less than 360 degrees, or 0 less than angle theta less than 2 pi if it's in radian, is defined as follows. So regardless of any degrees between 0 and 360 and 0 and 2 pi, we can still be able to find our reference angles. So if the terminal side is in quadrant 1, it's just basically the angle, and theta prime is just the angle of or given angle theta. So just the angle rotation between the terminal side and the standard position. No. If the terminal side is in quadrant 2, so what we're going to do is that we're going to use our given angle theta to find the angle theta prime between the x-axis and the terminal side. So if you're given with degrees, so if you're on the other side, quadrant 2, here, the x-axis, it's 180 degrees because it's a straight line. So if you're trying to find angle theta prime, we're going to use in degrees, we're going to do is 180 degrees minus our given angle theta. Now, if it was given in radians and we're looking for angle theta prime, all we have to do is, since the x-axis is over here, it's going to be pi. So we're going to do pi minus given angle theta. So that's how you would find angle theta prime, or our reference angle. If it was in quadrant 3, so we do the same process, but if it's in quadrant 3, that means that it rotated more past the x-axis, so that means it's going to be more than 180 degrees or more than pi. So if we're looking for the reference angle, or angle theta prime, all we have to do, if it's in degrees, our given angle subtracted by 180 degrees. If it was given in radians, so if our given angle theta was in radians, then our given angle theta, or our given radians, subtracted by pi. So that's how we're going to find our reference angle, or angle theta prime. Now, if your terminal side is in quadrant 4, so it's kind of like the work we did in quadrant 2. In order to find the reference angle, or angle theta prime, so if you recall, one full circle is 360 degrees, or 2 pi in radians. So since our terminal side is in quadrant 4, it's less than one full circle, meaning less than 360 degrees, less than 2 pi. So if you're trying to find the reference angle between the standard position and the terminal side, basically we're just finding the difference between our maximum rotation versus our given angle theta. So if our given angle theta was in degrees, all we had to do was do 360 degrees minus angle theta to find our reference angle, angle theta prime. If your given angle theta was in radians, then all we have to do is just simply 2 pi minus our given angle theta. Now, when it comes to radians, it's going to be working with fractions, so you need to be able to know how to work, meaning adding, subtracting, with fraction. So again, if it's given in radians, it's just basically 2 pi minus given angle theta to find angle theta prime. Here's a little note. To find a reference angle for angles outside the interval of 0 less than theta, angle theta less than 360 degrees, or 0 less than angle theta less than 2 pi, meaning if you have an angle that's more than 360 degrees or more than 2 pi, it says first find a corresponding coterminal angle in this interval. So basically, like, you're just going to go past the 360 degrees and then use what's remaining in order to draw your angle and then find the reference angle.